Okay, today we will practice the ideal gas law. We've gone over some of the important concepts, and we will try to apply the math. Notice that the sheet that has been given to you has the formula to be used, PV equals nRT. And over here I've given you the values that need to be placed in those places. For example, you need to have the pressure in kPAs, the volume in liters, the number of moles, of course, in moles. The temperature needs to be in Kelvin. And we've discussed the concept, the constant R is 8.31 liters times kPa divided by moles times temperature. Notice temperature has to be in Kelvin. So, if you need the Kelvin temperature and Celsius is given to you, you have to add 273. Or if you need the Celsius temperature, if Kelvin is given to you, you subtract 273. Okay, well, let's look at the first problem. Calculate the volume occupied at STP by 19.7 grams of methane. Methane is CH4, in case we've forgotten. Okay, now you have to use the formula PV equals nRT, but we need to isolate volume because that's what we're looking for. So we will change the formula to say volume equals nRT divided by pressure. Now, since grams are given to us and N equals the number of moles, we have to figure out how many moles of methane we have. And so we can just do that math over here. 19.7 grams of methane, convert moles. 1 mole of methane is 16 grams. Therefore, we have 1.23 moles of it. So that's N. So 1.23 moles R is the constant 8.31 liters times kPa divided by moles times temperature. T is the temperature. It says at STP. So recalling that standard temperature and pressure, the standard temperature is 273 Kelvin. And now we have divided by pressure. The pressure is 101.3 kPas because that's standard. Now we can cancel all our units. Moles are canceled. Pressure's canceled. Temperature's canceled. And the only unit left is liters. And it asks for volume, so that's the unit we need. So we will multiply 1.23 times 8.31 liters times 273 divided by 101.3. And our answer is 27.5 liters. All right, let's try the next problem. I'm going to move the page here a little bit. All righty. Now, here, it's asking us to find the pressure in a metal cylinder that contains 2.46 moles of argon gas. The temperature is in Celsius, 26.9 degrees. We're going to add 273 to that to make it Kelvin. It happens to be 300 degrees Kelvin. And it says the volume is 1.07 liters. So we will still use the ideal gas law formula, but we will again manipulate it so that pressure is isolated. So pressure will equal nRT over volume. The number of moles stated in the problem is 0.246 moles. R is 8.31 liters times kPa over moles times temperature. And the temperature is 300 Kelvin divided by the volume, which is 1.07 liters. So again, we can cancel our unit moles. We can cancel the temperature units. We can cancel our liter units, and the only unit left is pressure, and it says find the pressure. So everything's set up correctly. We multiply 0.246 times 8.31 times 300. Then we divide it by 1.7, and our answer ends up being 573 kPa.